Thank you very much for this kind introduction, and I would like to thank the organizers for inviting me to present in front of you, and I have to say it is a really great privilege for me. So I will be speaking on behalf of EFLM Patient Focused Laboratory Medicine Working Group on this subject that we are involved in right now. So by the end of the 20th century, the interest of patients to participate in making decisions regarding their own health has been increasing, and the patients expect to stay informed and to work with their physicians, as we've seen, on making decisions together. But despite this overall recognition about the patient's interest, there is a little consensus in the literature regarding exactly what patients require. And the conclusions of many review articles are that patients' preferences are highly variable. So although they are not connected to direct participation, the two major indicators of patient participation used for researches in this field are desire for health information and participation in decision making. So among the 7 types of information that patients typically desire in healthcare context suggested by the Health Information Wants framework, we have the important role of laboratory test results and the results of a research that was investigating the role of all of these elements in this type of framework suggested that patients, regardless of their age, expressed a bigger desire to have more information on the meaning of their test results than to have an active role, or not an active role, but more of autonomy in decision making in this field. And these results are in agreement with the results of our working group, which we have published in this paper that describes the results of a survey on patients' views from 8 European countries of interpretative support from laboratory specialists. And our results revealed that among the patients that wanted more information about their lab results, there was among the patients that wanted the insight, they wanted to receive directly their laboratory results, average of 72% wanted additional information, and among these patients, 30% would refer to the internet as the source of information. With the increased role of smartphones in our everyday life, there is an increasing possibility of continuous access to health information. And smartphones, thanks to their portability and their advancing performances, and together with software platforms that they are using, like the Apple's iOS or Google's Android or Microsoft Windows for phones, they are becoming suitable portables for special kinds of programs or applications called mobile applications or just simply apps. And these apps are used for delivering health interventions thanks to their accessibility to clinicians and patients at the point of care. And these apps are also capable for both local data storage and access to the internet. Also, the development cost is relatively low, which allows rapid development and really frequent updates. And mobile apps are also capable of utilizing the built-in features of many mobile devices, like cameras, accelerometers, microphones, speakers, and of course near-field communication. So thanks to all of these performances that mobile apps can, clinicians usually use mobile application as tools for clinical education. Also, they use mobile applications at the point of care in direct communication with patients, and also as a medical reference. In the app stores from which we can download mobile applications, health applications, they are usually categorized in some kind of categories which are defined in these app stores. And health-related apps are usually categorized as health and fitness and medical apps. If they are categorized as health and fitness, usually they are aimed for daily use by patients, but not exactly patients, but any person who is interested in his own health. But applications that are categorized as medical are aimed either for medical professionals or as supportive apps for patients with a medical condition. But this category designation is not universal, but it is given by the developer. So it is not unusual that between the medical applications, we find numerous apps that would not qualify as medically relevant, like the pharmaceutical companies' apps functioning as advertisements, insurance company portals, or apps for solicitation of illicit drugs. So this makes this kind of classification unreliable, and therefore we cannot recommend this classification for searching the app of particular features. So how do we find an app with specific performances and with specific features? It is not easy, especially as we can see there in the year 2017, there was 325,000 health apps available, and they were developed by more than 84,000 publishers, which is stated in this Research to Guidance report. So most of these applications are designed for people who want to manage or prevent chronic disease. What is challenging is to find an app with certain performances and quality of information, and within the App Store, search results usually vary by user. They vary depending on the store's proprietary algorithms. And which is also important to know is that these App Store search engines do not recognize Boolean logic. So if we search by a certain parameter, certain word, or an expression, in return we will get a number of relevant results, but they are based on search terms found either in app titles, in descriptions and keywords, but also contextual keywords and competitor brand names. So also search results are usually ordered partially on relevance, but this relevance is taken by the relative ranking in terms of number of downloads. On the other hand, governments do not regulate the content of mobile health apps unless they function as part of a medical device. So, though the American Food and Drug Administration has developed a guideline on whether and which mobile health apps should be considered medical devices and therefore be considered under this government regulation, most apps are not subject to regulatory oversight. So, quality in the context of an app store typically refers to apps users' interface design and the performance and stability of the software program. But it is not necessary that App Store checks all of these performances, and the only store that reviews apps in advance before publication is iTunes, but they only review them as software products, not in the sense of apps' effect on consumers' health outcome, of course. National Institutes of Health, U.S. National Library of Medicine, has delivered a simple guideline for patients how to evaluate information that they find on internet websites concerning their health. And they have made a simple tutorial which is accessible to patients. And this tutorial practically is designed around a checklist of questions that one should ask when browsing any website. And these answers provide clues about quality of information on the site, and they can usually be found at the very beginning on the home page or at the About Us, in the About Us area. And these questions in the checklist are organized in 4 sections. First section considers the provider. Second section deals with funding. Section 3 is considering quality, and section 4 is about privacy of information. Also, within this tutorial and on this web page, there is an advice that patients should consult several high-quality websites to obtain a wider view of a certain health issue of their interest. And also, besides this checklist, on Medline Plus web page, which is part of, on which there is this tutorial and all of this guidance. There is also many other useful information for patients, like the list of highly trusted resources on specific medical conditions, like the American Heart Association, American Diabetes Association, CDC, etc. But this is all concerned about the internet and website quality of information. And what about the mobile apps, which are our prime interest here, I must say. So these are all attempts to evaluate the quality of mobile health applications using different approaches. Some of them have used the checklist which was developed for patients' evaluation of internet health information. Other ones try to use instructions or references for the systematic review of literature, and all of them have obtained different results. For example, this group of Chinese authors, Xi and Associates, have used the previously mentioned instructions and checklists of the National Library of Medicine to evaluate the information quality in Chinese cardiovascular disease mobile apps. And they have designated that the presence of every item from the checklist should carry 1 point. If this item is not present, there will be no points, and the app with the most points will have the best information, will carry the best information quality. This is the multidimensional framework for assessing health app quality, and this was systematized by Grundy and Associates out of 91 publications that were dealing with quality of information within mobile health apps that were oriented for the consumers, meaning for patients. And within this framework, we can see that assessing health app quality must consider scientific or clinical basis, meaning what is the scientific quality of the information within the app and what is the clinical value of app's intended purpose. Also, functionality, how well does the app work for its purpose, usability, how well does the app engage the user, accountability, how credible it is, what is the risk of bias, impact, what kind of work does the app do, and finally, popularity. So how well is the app liked, which would be the information obtained from the rankings in the App Store. Another approach would be through a mobile app rating scale. Mobile app rating scale was delivered by a group of Stoyanov and Associates, a group from Australia, which represent which comprehend multiple perspectives of quality of a mobile app. This approach in the beginning has a part where we have to represent descriptive elements of every app, meaning to identify the app through app's name, developer version, then ratings, overall ratings from the App Store, also total number of ratings, last update of the version, cost if we have to pay for the download, and also affiliations of developers, also the category. Also in this descriptive part, there is identification of technical aspects of app present. These technical aspects involve the possibility of sharing the information and sharing the app on social networks, then whether the app had an app community, does it allow password protection, does it require login, send reminders, does it need web access to function. So, the Mars app quality criteria are systematized into 4 categories, and they are divided into 19 subcategories representing 19 individual Mars items. First category is engagement, second functionality, third aesthetics, and fourth information quality. And within each one, as you can see, we have individual items that in summary represent the score for the individual quality element of the Mars score. Each item uses a 5-point scale. First, number 1 would be inadequate, through poor, acceptable, good, up to 5, which would be excellent quality in each of these performances. And if an item cannot be applicable for all the apps, then there is a not applicable option. Mars is scored, meaning total score, is scored by calculating the mean score for each of the 5 categories. So, for example, in the first section engagement, we have 5 questions regarding individual items. The answers to every question carries certain amount of points, and the average scoring of all the answers is engagement mean score. So in the same way, we can calculate functionality mean score, aesthetics mean score, and information mean score, and the average of these 4 scores represent app quality mean score or Mars total score. The 5th element is app's subjective quality score or subjective total score, which is deduced from this special separate section of the impression, individual impression that app leaves on a user. Of course, there are many health apps out there, but we were interested to see how many apps involve laboratory medicine data. Because, as we all know, laboratory test results are among the most important healthcare information, since the significant number of clinical decisions are, of course, based on them, and the use of laboratory medicine data in mobile health apps, as well the quality of related information, has not yet been evaluated. In a talk yesterday, we've heard that PubMed search would give as a result 42 publications dealing with health apps, but none of them had laboratory medicine data involved. And this is why our working group has decided to try to search the online stores market for Android and for iPhone as the two mostly used smartphone platforms for health apps that manage in any way users' laboratory medicine data in order to review them and perform a quality evaluation. So this is a flowchart that describes app selection process. We have searched the Google Play Android App Store and App Store for an Apple, so-called App Store or iTunes in Serbia. It is very important to distinguish in which country we use the App Store because the search results may vary between countries. Search criteria that we have entered were lab results blood work, lab results and health apps, and we have performed the search in the period from January 2017 up to May 2018 before the start of this conference. And these search criteria yielded in total 1,247 apps that were in any way connected with these searching terms. Of course, after the screening of their content in through the descriptions in their app stores, we have to exclude some of the apps. Those were the so-called prank apps that would offer to measure glucose concentration or cholesterol concentration through finger scan, and also those who only mentioned laboratory data as such, but they haven't in any way dealt with them. After that screening, the remaining number of apps was 95, 29 for Google, for Android, 50 for iPhone, and 16 of these health apps were available on both platforms. In order to, up to this point, the information about the content of these health apps was taken and only from the description of the App Store. For further analysis of information quality and functioning of every app, we needed to download them. So after this process, we also needed to exclude more apps. Why? Because some of them were requesting a financial fee for prior to download. Then another group of apps that had to be excluded are those who could only be, after download, who could only be accessed with specific login data. And the third group that we have to exclude are those who were unresponsive after download. So we couldn't open it, we couldn't do anything with them. So finally, for the final analysis, we ended up with 52 apps, 27 for Google, Android, 9 for iPhone, and 16 for both of them. According to the description on the apps within the App Store, we could categorize those 95 apps into 7 categories according to their content and their function, their utility, their aim. First category were the apps that would offer medical advice about symptoms and health queries with the possibility to upload laboratory test results which can be seen, stored, and shared. 10% in total. Then we have the most important group that would represent reference ranges of selected analysis with basic information about the causes of increase and decrease designed for patients. In total, 16%. Then the third group, quick reference for laboratory tests for medical students and doctors. So they also wanted a reminder of the meaning of laboratory test results, and they were, in the beginning, 30%. apps for monitoring the state of users' health through a wide range of health parameters, including glucose and/or cholesterol as the most frequent laboratory data used within these apps, were 20%. Fifth category, apps that provide access to patients' laboratory results to physicians, 11%, 11.6. Apps that enable patients to access their laboratory test results directly from the diagnostic center, 4.2, and electronic health record apps that include laboratory test results, that would be about 7%. However, when we, after the download, the apps that were eligible for the complete analysis were only 52, as I have mentioned, and during this process, in the group 5 and in the group 7, there were no apps that we could analyze. So, all of them in group 5 and 7 requested login information from a designated laboratory that would provide laboratory tests for patients, and the percentage was then a little bit changed, and those most important for us reference ranges for patients were about 36.55% of the total apps analyzed, and also the references for medical professionals were 38.5%. So, we performed the review and content analysis of all of these apps using the MARS approach. But besides the MARS items, we also added in the analysis the elements that might be considered particularly important for the field of laboratory medicine, meaning, first of all, comparability with locally accepted reference ranges, then units of concentration used, use of appropriate terminology for designated group of users, and transfer security for uploading and downloading data, which was defined with clear and visible statement of privacy policy within the app or in the description of the app. Also, we have included in the analysis the affiliation of app producer, which was already described in the MARS questionnaire, as an indicator of the credibility of information used within the app. So these are the descriptive data that we have obtained. So first of all, we can see that within the App Store, we got really high rankings, really high user rankings for all of these apps, 4.2 for Android and 4.7 for iPhone. But as we can see, the number of ratings wasn't really high, and even very, very low, the median number of ratings on the iTunes. Also, the apps were relatively up to date. The median year of last update was 2017. Some of them were even updated a few months ago. So, as we can see, most of the apps, unfortunately, were commercial, but on the second place, we didn't know who was the developer. There was an information only in the place where the information about the developer should be. We only had the email address. No other information, no other links to websites, nothing. Of course, as expected, most of the apps were categorized as medical, and another group would be health and fitness. As for the number of technical aspects present per app, we can see the median number was 0, meaning that most apps didn't have any of these technical aspects that were indicators of app quality. Most of them had 1, 2, up to 3. Among those who had some of these technical aspects, the greatest number was the possibility of sharing on social networks, and the lowest number had an app community. As for the MARS ratings, MARS total score was relatively high, 3.8, but it ranged from 2.2 up to 4.8. If we considered the individual items, the best rating would be for functionality and the worst for engagement, only 2.6, while aesthetics and information quality had relatively high scoring of 3.7 and 3.8. To remind you, 5 is the highest score. Interestingly, subjective quality was lower than the total score. If we consider the elements that we have introduced specifically for laboratory medicine data, we can see that most of the apps used either conventional or both conventional and SI units. What does it mean both? Meaning that they offer possibility to choose between SI and conventional units, or they use SI units for some parameters and conventional units for others, and also some of them offered a conversion factor. We performed permanence correlation analysis, and we found that there was a good, significant correlation, positive association between individual MARS scoring with subjective quality and number of technical aspects. Also, total MARS score and individual items were significantly correlated with the affiliation of the app developers, and there was no significant correlation between the ratings from the App Store and, of course, the MARS score, which is also expected. Also, when we have compared the individual values in the 7 categories of apps that we have distinguished, we can see that there was a significant difference between categories in number of technical aspects, engagement, informational quality, total score, and subjective quality. And the worst ratings, the lowest values were in the second category. To remind you, the second category is the category dedicated to patients with reference values with explanations for patients. Of course, we have a lot of limitations with this research. First of all, we have not evaluated the impact these apps have on their intended users, meaning patients or medical professionals. And of course, we need to know whether the use of these apps leads to change in behavior. Does it increase health awareness? Does it brings to understanding of laboratory test results and their impact on personal health? So maybe one direction would be the one that Macmillan and Associates have used for developing a rating tool for health behavior change apps, which of course had 62 items to analyze. But I'm really excited to talk with Dr. Whitman about this aspect. So the question is also, could these nice guided criteria be customized to an appropriate form for laboratory medicine apps? And of course, we use the MARS rating for apps quality assessment, which is a general tool which is not yet evaluated on laboratory medicine app. This is the first work using MARS for laboratory medicine, and MARS has yet been evaluated only on health apps for mental health and for weight loss. And of course, the question is, are the MARS rating tool and its criteria in general form enough for review and content analysis of the laboratory medicine data? If they aren't, is there a need, and is there a space for modification? So this would be the conclusions. The most important, according to me, is that these apps designed for patients, which we can consider the vulnerable group, are of the poorest quality, as we saw, and considering the total quality of the content and information they provide, of course, estimated using the MARS tool. And this estimation, of course, needs to be validated for laboratory medicine apps, and eventually has to be modified after consideration of specific quality benchmarks, which would be our next goal goal in the working group. This is our working group, and of course I invite you to visit our page on EFLM website. And with this first solar-powered mobile charger developed by the Strawberry Energy company, originated in Serbia. These are smart benches where you can sit, relax, and recharge your phone after using so many health applications. And this one is situated in center of Belgrade in Tašmajdan Park. I thank you for your attention, and I apologize for breaking the time.